This video is on quadratic functions. We're going to look at domain, range, maximums, minimums, and graphing. So domain is just the x values. Range represents the y values. So we're going to look at the parent function. That's the most basic type of quadratic function, y equals x squared. So in this function, the domain is all real numbers because there's not a restriction on what we can plug in for x. We can plug in anything. And if you notice, as this is just going to continue going up and out forever. So if it continues going up and out, all of the x values, both directions, will be included as part of the graph. So domain is all real numbers, also written like that. So you can write it out or just write the symbol. Range is y. So on this graph, we can see that it's going to continue going up forever, but this is the lowest point. So your vertex, which is the lowest point, helps you identify the range. So you're always going to look at the y value of the vertex to identify the range. In this case, it's 0. So I know that in this graph, y is always going to be greater than or equal to 0 because it's never going to drop down into the negatives for any y values. Okay, always look at that vertex. So the vertex is just the bend, so it could be at the bottom, or if it's reversed, it would be at the top. The vertex in this case is considered a minimum because it's the lowest value you'll ever get to. If it was reversed, the vertex would be a maximum just because it would be the highest point of your graph. The axis of symmetry goes right down through the vertex. It's a vertical line. It goes down through where x is equal to 0. Because this is the x coordinate, would be 0 right down through that vertex. And the x-intercepts, the point where your graph crosses the x-axis. In this case, it crosses or touches just once where x is 0. So the x-intercept is 0. So we're going to look at all those features right now. Okay, so our first one, we have f of x, which is the same thing as y, is equal to negative x squared minus 2x plus 3. So we're going to start by finding the vertex. So the vertex, we're going to find the x coordinate. So the x coordinate is negative the b value, which your b value is multiplied by x, which in this case is negative 2, over 2 times the a value, which in this case is negative 1. So negative times a negative is a positive. So we have positive 2 over 2 times negative 1 is negative 2. 2 divided by negative 2 is negative 1. So the x coordinate of the vertex is negative 1. All right, now I have to find the y coordinate. So I'm going to plug in negative 1 back in for x. So I have, remember f of x just means y, is equal to a negative times x is negative 1 squared minus 2 times negative 1 plus 3. All right, so we have negative 1 squared is 1, but we have to have that negative on the outside. So it's a negative times our 1 is negative 1. Negative 2 times negative 1 is positive 2 plus 3 gives me 4. So I know my vertex is going to be where x is negative 1, y is 4. And my axis of symmetry will go right through the x coordinate, so it'll be x equals negative 1. If I want to, I can draw this straight down so I can make sure when I'm graphing it, the two sides are symmetrical. All right, so all this other information, I can figure it out as soon as it's graphed. Easiest way to graph is using a table. So I'm going to find two x values to the left, so negative 3 and negative 2, 2 to the right, where x is 0, x is 1, and I'm just going to use a calculator. I'm going to plug in negative 3 for x. So I have a negative times, I always put it in parentheses, So negative parentheses, negative 3 squared minus 2 times negative 3 plus 3. And when you put that in the calculator, you get out 0. Okay, next I'm going to put negative 2 in the calculator. So negative parenthesis, then I have negative 2 squared minus 2 times negative 2 plus 3 gives 3 as a value. Okay, plug in 0. Well, we'll have 0, 0, because anytime you multiply times 0, you'll get 0. So we're left with just 3. Plug in 1. So we have negative 1 minus 2 plus 3 leaves me with 0. Okay, so I'm going to graph these. When x is negative 3, y is 0. When x is negative 2, y is 3. When x is 0, y is 3. And when x is 1, y is 0. So this tells me that this is what my graph will look like. And I have to make sure I kind of curve it, so it shouldn't be a V shape. It should be a more curved U shape. Okay, so now I can look at a few things. So I have to decide, is the vertex a minimum or a maximum? Well, it's a maximum because my graph's never going to go above this point. This is the highest it's going to get. So it is a maximum. My domain, most of the time, unless you have some sort of restriction, when you're working with quadratic functions, as long as it doesn't tell you x has to be restricted by anything, you know that your domain is all real numbers when you're working with quadratic functions. So the range, this is looking at the y values. Remember I said look at the vertex. The vertex of the y values is 4. Well, that's also the highest point, obviously the y value, that my graph will ever get. So my graph is always going to be less than where y is 4 or equal to. So y is less than or equal to 4. So really all you need to figure out which direction is the sign pointing. It's going to include everything less than. All right, x-intercepts. This graph goes through the x-axis at negative 3 and it goes through the x-axis at 1. So those are my x-intercepts. Okay. Now I'm going to solve this. I'm going to factor it. I don't want my x squared value negative, so I'm just going to factor out negative 1. And I get x squared, factor out that negative, and it's positive 2x. If I factored out a negative, my positive is now negative because a negative times a negative gives me a positive equals 0. Okay, now I can figure out what can I add together to equal 2, what can I multiply together to equal negative 3. So in this case, we have 3 and negative 1. So this factors to x plus 3 times x minus 1 equals 0. Remember to solve, you're going to set each of these individually equal to 0. X plus 3 equals 0, and x minus 1 equals 0. So we're going to subtract 3 on both sides to get x equals negative 3. I'm going to add 1 to both sides to get x equals 1. All right, hopefully you noticed something. Our x-intercepts and our solutions are the exact same thing. So solutions and x-intercepts, they mean the same thing. If you have a quadratic function, it's a point where your graph goes through the x-axis. All right, let's try another one. F of x equals x squared minus 9. Okay, so on this one, I'm going to start by finding the vertex so I can graph that. Remember, x equals negative the b value. B value is what's multiplied by x. X isn't there, so it means this would be x squared plus 0x minus 9. Anytime you don't have x there, it means that 0 is multiplied by it. So the b value is 0, so negative 0, divided by 2 times the a value, which is 1, because there's 1x squared there. So that gives me x equals 0 because, well, negative 0 is just 0, and 0 divided by anything is 0. So for my vertex, the x value is 0. That means my axis of symmetry is x equals 0. To find the y value, I'm just going to plug 0 in for x. So I have 0 squared minus 9. 0 minus 9 is just negative 9. So the y value is negative 9. So that tells me x is 0, y is negative 9, way down here. Okay, my axis of symmetry for x equals 0, so I'm just going to do a dashed line through x equals 0. All right, now I need to choose some values to the left and right so I can graph. So I'm going to choose where x is negative 2, negative 1, 1, and 2. Okay, so I chose 2 to the left of the vertex, 2 to the right. Now I'm going to plug in negative 2. Negative 2 squared is 4, and 4 minus 9 is negative 5. Plug in negative 1. Negative 1 squared is 1. 1 minus 9 is 8. I'm going to plug in 1 again. 1 squared is 1. 1 minus 9. Sorry, that was negative 8. I left off my negative. It's negative 8. Plug in 2. 2 squared is 4. 4 minus 9 is negative 5. So I'm going to graph these. I like to choose 2 to the right, 2 to the left, but if you notice, if I graph these, when x is negative 2, y is negative 5, they don't quite meet the x-axis. So I'm going to have to choose some more points, but I'm going to graph these so you can see. I need my graph to continue going up, so I'm just going to go out a little further. And it's easy to just start with picking your 2 to the left of the vertex, to the right. And if you need more, choose more, because you want to know where your graph goes through the x-axis. So I'm going to go further left to negative 3 and further right to positive 3. So I'm going to plug in negative 3. Negative 3 squared is 9. 9 minus 9 is 0. I'm going to plug in positive 3. 3 squared is 9. 9 minus 9 is 0. Hopefully you know that when y is 0, that's on the x-axis, so we found it. So when x is negative 3, y is 0. When x is positive 3, y is 0. So when I graph this, make sure I round that a little bit. It will continue going up, and that one will continue going up. All right. Well, that tells me that this is a minimum. The vertex is the smallest value it'll ever get to. So I have a minimum. My x-intercepts are where x is negative 3 and positive 3. All right, now domain and range. Domain is all real numbers. There's no restriction on x, and as it continues going out, well, all the x values will be included as part of the graph. There'll be points on the graph. The x values will be actual coordinate pairs. All right, range. My graph's never going to get below this point. It's going to continue going up, so all these y values will be included, but this is the lowest point. So y, down here is negative 9. It's going to be greater than or equal to negative 9. All right, one more thing I need to do. I need to solve. But remember, when you're solving, 0 actually has to be on the right side. So I'm going to move it to the other side. I'm going to add x squared to both sides. Get x squared equals 9. Subtract 9 on both sides, and I get x squared minus 9 equals 0. Okay. So that's the same thing as x squared plus 0x minus 9 equals 0. So I have to figure out what I can add together to equal 0, multiply together to equal negative 9. So in this case, I have 3 and negative 3. So x minus 3 times x plus 3 equals 0. Solve each individually for, here we have x plus 3 equals 0. I'm going to add 3 to both sides to get x equals 3. Here I'm going to subtract 3 on both sides to get x equals -3. And my solutions are the exact same thing as my x-intercepts. So now I'm going to have you try 2 problems. Here's the first one. Go ahead and you can pause it here, go through and do this one. I'm going to move it. Here's the second problem. Go ahead and pause it, do the problem, complete it, and I'll go through the answers with you. All right, so this first one, the vertex, x equals -2 over 2 times -1. -2 divided by -2 is +1. So 1 is the x value, which is also the axis of symmetry. Plug that in for y. 1 squared is 1, and I have that negative on the outside. Plus, plug in 1, 2 times 1 is 2, plus 8 gives me y is equal to 9. So we have 1, 9 here. And now I'm going to plug in some x values. I'm going to use, I know I need to do -2, -1, 0, 2. I'm going to extend this out because I know already that I have to extend it out, 3 and 4. Okay, so when I plug -2 in for x, I get 0 out for y. When I plug in -1 into my equation, to my function, I get 5. When I plug in 0, it's 8. When I plug in 2, I also got 8. Plug in 3 for x, you get 5. Plug in 4 for x, and you get 0. So I'm going to graph these. -2, 0. -1, 5. 0, 8. 2, 8. 3, 5. And 4, 0. Okay, graph that. Then I know that this is a maximum. I have all real numbers for domain. Range, y is going to be less than or equal to 9 because my graph is below 9. Okay, x-intercepts. I have x equals -2 and x equals 4. Okay, then I'm going to solve this one. I'm going to factor out -1 to get x squared minus 2x minus 8 equals 0. When I factor it, what adds together to equal -2 multiplies together to equal -8 is -4 and +2. So x minus 4 times x plus 2 equals 0. I'm going to set them each individually equal to 0 and solve for both. Add 4 to both sides to get x equals 4. Subtract 2 on both sides and I get x equals -2, which are my x-intercepts. All right, last one. Okay, vertex. We have negative, this is the x value, -4 is b over 2 times a, which is 1. Negative times a negative is positive, so I have 4 over 2, which is 2. Axis of symmetry is x equals 2. Plug in 2 for x. We have y equals 2 squared is 4, minus 4 times 2 is 8, plus 3. So we're given this, it equals -1. So x is 2, y is -1. All right, I'm going to choose 2 points to the left, 2 points to the right of that vertex. I'm going to choose 0, 1, 3, and 4. When I plug 0 in for x, I get out 3. When I plug in 1, I get 0. When you plug in 3, you get 0. And when you plug in 4, you get 3. Hopefully you already did this, so I'm going through it a little quicker. When x is 0, y is 3. When x is 1, y is 0. When x is 3, y is 0. And when x is 4, y is 3. So here's my graph. Make sure it's kind of U-shaped. All right, domain is all real numbers. Range. Y is going to be greater than, because my graph's above a certain point, greater than or equal to -1. You can see it down here. This is a minimum. It's the lowest point it'll ever be. My graph never goes below that. X-intercepts are 1 and 3. Okay, so again, I have to move everything to the other side because when I solve down here for x, when I factor, it has to be equal to 0 on the right. So I'm going to add x squared to both sides. X squared equals 4x minus 3. Subtract 4x on both sides to get x squared minus 4x equals -3. Add 3 to both sides, and I have x squared minus 4x plus 3 equals 0. All right, so I'm going to factor this. So I have to figure out what adds together to equal -4, multiplies together to equal 3. And that's -3 and -1. So I'm going to solve x minus 3 equals 0 and x minus 1 equals 0. Add 3 to both sides to get x equals 3. Add 1 to both sides to get x equals 1. And those are my x-intercepts.